Hello everyone, welcome back to my YouTube channel. So, if you are new here, my name is Sinchana, a first year engineering student. In this channel, I gonna share my new skills, new things, what I learned day by day. Okay, in this video, I gonna teach you the C programming. Okay, the structures of C, the data types of C, and the different computer level languages. So without any further ado, let's understand what is computer languages. The computer level languages, so we need to understand what is computer languages. Computer level languages are the languages used to communicate with a computer. So we need one language to communicate with a computer. Okay, it can't understand human level languages, so we need one language to communicate with a computer. So that language is called as a computer languages. So based on how close they are to the computer hardware and human language, computer level languages are divided into three types: machine level languages, assemblage or symbolic level languages, high level languages. So the computer can't understand the human level languages, so we need to have one language that can understand the computer. So the computer can be divided into machine languages, assemblage or symbolic level languages, or high level languages. Machine level languages. Machine level languages is the very lowest level of languages then assemblage or high level language. It's the very lowest level of languages. It consists only of zeros and ones, which is called a binary digits. Machine level languages is only made up of zeros and ones. It does not made up of English languages. It only made up of zeros and ones, which can understand computer can understand the zeros and ones. The computer can't understand the English level languages like if, else, return. It can't understand. It only understands zeros and ones. The computer understands these languages directly, so no translator is required. Okay, the machine level languages does not need any translator because it already exists in the machine languages. But in assemblage or high level languages, we need a translator because it is in a symbolic, because it is in the symbols, or in the English level languages, we need to translate that in the computer level languages. I hope you understand. Okay, but machine languages is very difficult for humans to write and understand. Yeah, the machine languages the humans can't understand. Okay, the computer can't understand human level languages. The same, the humans can't understand the computer level languages. I hope you understand what is machine languages. Okay, next, assembly level languages. Assembly level languages uses symbols and instructions instead of binary numbers. So in machine languages we use zeros and ones, but in symbolic level languages we did not use a zeros and ones. Instead of we use a symbols. Okay, assembly level languages uses symbols or instruction instead of binary numbers. I hope you understand. So in by machine languages we use a binary digits like zeros and ones, but in symbolic level languages we does not use zeros and ones. Instead of binary digits we use as symbols and instructions instead of binary digits. Examples. So we use examples like move, 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 or add, or sub. So these are basic examples for symbolic level languages. So we do not use a binary digits here. Instead of we use a symbols or some statement, some instructions we use. Okay, it uses an assembler to convert the program into machine languages. So the computer can't understand these languages. Move, add, sub, the computer can't understand. So we need a translator. That translator is called as assembler. So the computer can't understand these languages, so we need a translator. That translator is called as assembler. It uses a assembler to convert the program into machine languages. So the computer can't understand. So the computer can't understand this move, add, sub. So we need a translator. The translator is called as assembler. That assembler translator converts this program into machine level languages. So in machine languages there is no translator because it already exists in a machine level languages. But in a symbolic level languages we need a translator. The translator is called as assembler. So assembler that translate a program into machine level languages. I hope you understand the difference between machine languages and symbolic level languages. The machine level languages uses the binary digits. It already exists in a machine level languages. There is no translator, but in a symbolic level languages, uh, it is made up of symbols, and it need a translator to translate. You need a translator called as assembler to translate symbolic level languages into a machine level languages. I hope you understand. Next, we're gonna learn a high level languages. It's very important. Okay, let's learn high level languages. What is high level languages? High level languages are easy to humans to read and write and understand. Okay, the high level languages is are easy for humans to read and write and understand. It was for easy for humans to read and write and understand. Okay, so high level language is a programming language that is easy for humans to understand and write. Okay, it was difficult for computer, but it was easy to humans to understand and write. Okay, high level languages are easy to understand. They are close to human languages. They are user friendly. No need to know hardware details. Example: C, C++, Java and Python. So they are not machine dependent and can run on different systems. So they are not machine dependent, they can run on different systems. Okay, next they use compilers or interpreters to convert the program into machine languages. These are a completely human level languages that computer can't understand. So we need to translate any languages into the computer level languages, because the computer need to understand the human languages. It can't understand human level languages, so we need to translate human level languages into computer level languages. So we need a translator. The translator is called as a compiler or a interpreter. I hope you understand. The high level languages is a programming language. It's easy for humans to understand, right? They are not machine dependent, can run on different systems. They are not machine dependent, they can run on different systems. Okay, next they use a translator to translate into computer level languages, a compiler or a interpreter. So we commonly use high level languages instead of a machine level languages or a symbolic level languages. We commonly use high level languages. It can run on a different system. Okay, so there is a translator. Okay, the translator is called as a compiler or an interpreter. We use a compiler in a C program, interpreter in a Python. Okay, so there is a translator called as compiler or interpreters to convert the program into machine languages. For example, C, C++, Java and Python. So in these three, high level languages is most important. So please focus on high level languages. Nothing much about this. High level languages is the completely human level languages a human can understand easily, like it, if, else, and written statements. It's all are high level languages. Okay, high level languages easy to understand, they are close to human languages, they are user friendly, no need to know hardware details. I hope you understand. Next, move on to next slide. What are the advantages and disadvantages of the high level languages? Advantages: easy to understand, faster program development, less errors, easy debugging and maintenance. So disadvantages: lower than the low level languages, needs a compiler or an interpreter, less control over hardware. So now let us understand the advantages and disadvantages of high level languages. High level languages are designed mainly for humans, not for machines. Okay. High level languages are easy to understand because they use English like words, because they were easy to understand for humans, because they are using English words like written, if else, or print. These are like human level language. You can understand easily what is written, what is print this, what is written. Okay, so beginners can learn high level languages easily. Faster program development means we do not need to write a long binary or machine instructions like zeros and ones. We did not want to write long binary digits. Instead of we use like print this or return or if, we can use this. So less errors. Because of this, the chances of making mistakes are less if high level languages have clear syntax and rules, and because less errors, because the chances of making mistakes are less. Many errors can be detected by the compiler itself. We are easy to know the errors, what the errors, we can easily fix the errors in high level languages. But in computer language it was difficult to uh, fix the errors and find out the errors, because it's in a computer language we can't understand. In high level languages we can understand easily, because it's in a human level languages, it is in a English words. We can easily understand the errors and we can easily fix the errors. Okay, next, easy debugging and maintenance. Debugging means finding and fixing errors in a program. Okay, we can easily fix the errors and we can easily find out the errors, what is the error is. But in computer languages we can't even understand what is the error, we can't fix it. But in high level languages we can easily understand. Okay, next, in high level languages errors are easy to find and correct. Also, modifying or updating the program later is simple, so maintenance is easy. Also, modifying or updating the program later is simple, so maintenance is easy. I hope you understand. It was easy to understand, faster program development, less errors, easy debugging and maintenance. Disadvantages: high level languages are slower compared to machine level and assembly level languages. This is because the code must be translated before execution, because it need to translate before execution. So the high level languages are a bit lower than the computer level languages. So needs a compiler or an interpreter. High level languages cannot be understood directly by the computer, because the computer can't understand directly high level languages, because it's fully in human languages. It can't understand. How we can't understand the computer languages? Because it's zeros and ones, we can't understand a single line. Same way the computer can understand human languages, so there will be a compiler or interpreter. We need to convert the program into machine languages. So less control over a hardware. In high level languages, the program does not have a direct control over hardware. Low level languages are better when we need hardware level control. I hope you understand what are the disadvantages and advantages of the high level languages. So high level languages are easy to learn and use, but they are slower and give less hardware control. I hope you understand what is high level languages and what are the three different types of high level languages. So the computer languages are mainly divided. The computer languages are languages. So computer level languages, the languages which can easily understand by the computers, we the humans can't understand. So the computer language is divided into three types: machine languages, symbolic level languages, and high level languages. Next, the high level languages, the languages is a programming language that is easy for humans to understand and write. The high level languages are easy to understand, they are close to human languages, they are user friendly, no need to know hardware details. Next, advantages and disadvantages. Was easy to understand, slower than the lower level languages, it's faster program development, needs a compiler or interpreter, less errors, less control over hardware, easy debugging and maintenance. I hope you understand what is a C program, what is a computer languages, what are the different types of programming languages, what are the advantages and disadvantages. Now let us understand a data types in C programming. This slide says that what is data types. The data types tells the compiler what type of data a variable can store. So data type tells the compiler what type of data a variable can store. So it tells the compiler what type of data, like it will be a integer or it can be a decimal value, it can be a character, what type of data a variable can store. In simple words, the data types decide what kind of value we can store in a memory. So there were many data types we commonly use. We usually uses these data types: char, int, float, double, void. These are the basic data types. Char is a character, means it stores a single character like A, B, C or any symbols. In C, character always written inside a single quotes. In characters, in C, the characters are always written in a single quote. Okay, not a double quote. The characters are written in a single quote. For example, I'm gonna show here cat grade is equal to A. So this is the example for cat. Here A grade stores only one character, that is capital A. Here grade stores only one character, that is a capital A. I hope you understand the char occupies only one byte of memory here. So here grade stores only one character, that is capital K. Next move on to next data type. So here int means integer. It stores a whole number, not a decimal number. It stores a whole number like 0, 1, 2, 3, -1, -2. Whole numbers do not contain any decimal points. Examples are like 3, 5, -10, 0. For example, I'm gonna show here. Sorry. This is the example for integer int data type. So here age stores a whole number value. Here age stores the whole number value. This is the example for integer. Here integer stores a whole number value. There is no decimal point here. So why there is no decimal point? This is the integer value. Int cannot store any decimal values. I hope you understand what is int data type. Next, the float. The float stores a decimal number with less precision. The float stores decimal number with less precision, means here there is no whole number, it stores only a decimal number with a less precision. It stores decimal number with fractional parts. Float has a less precision, which means fewer digits after the decimal point. There will be a few digits, not more digits. In a double we can see a more digits after the decimal point. In float there is no more digits after the decimal point. There is a difference between a float and a double. The float also stores a decimal number, double also stores a decimal number, but float stores a decimal number with a less precision, double stores a decimal number with a more precision. This was the most common difference between the float and the double. Both stores a decimal number with less precision and more precision. I show an example here. Float marks is equal to 3.14. So this is the example for the float value. Here it stores a decimal number, not a whole number. It stores a decimal number with less precision after the decimal point. I hope you understand the float is mostly used when we use it approximate values. Float uses 4 bytes. Here character uses only 1 byte, but a float uses a 4 bytes of memory. For example, for doubles, what is meant by double data type? It also stores a decimal number with more precision. The double data type is also used to store a decimal numbers, but double stores value with more precision than float. It can store more digits after the decimal point. Example, double pi equal to 3.1451459 semicolon. So here after the decimal point there were more digits, but in a float after the decimal point there will be a less digits. This was the most common difference between the float and the double. Both store the decimal number, but there is a less precision and a more precision. Double is preferred when accuracy is important. Double uses more memory than float. Next we will move on to a void. What the void data type means nothing. It is mainly used with functions. It tells that the function does not return any value. It tells that the function does not return any value. If you use void function instead of int in the main function, if we use void, we do not use a return statement here. This function only displays output but does not return any value. It only displays output but does not return anything. It does not return any value. For totally, the char stores as characters, int stores the whole number, float and double stores the decimal numbers with less precision and more precision, void stores nothing. So I give an example for void here. Void display void sorry void display enter, and here flag bracket enter, printf printf hello hello. So this is an example for the void statement. We do not want to return a return statement here because we use void. It does not return anything. It does not return any value. This all are the example of data types. It is an example for the char data type. It's an example for the int data type. It's an example for a float data type. It's an example for the double data type. It's an example for the void data type. So data types in C specify the type of data a variable can hold, such as a character, integer, decimal, or a no value. I hope you understand what is a data types and what are the different types of data types. Here, these all are the examples of the data types. Here, char stores a single character that are stored in the single quote A. These are the example for a char data types, and it is an example for the int data types. It stores age as a whole number. And these are float data types. Float data type stores a decimal number. Int data type stores only a whole number, but float data types and a double data type stores a decimal number with less precision and a more precision. Means after the decimal point there were a less precision, means after decimal point there were less digits, but in a double there were double is also made up of also stores a decimal point after a more precision, means a more digits. Void does not return anything. It does not return anything or does not return any value. These all are the examples of the data types. These all are the example of the data types. It's for a char data types, it's for int data type, it's for the float data type, and it is for the double data type, and it's for the void data type. Advantages of high level languages, I hope you understand. Here this slide shows the basic structures of the C program. Every C program follows these structures to run correctly. Let us understand each part one by one. The first, this is the structure of C program. First, we understand the header file, include stdio.h. The first line says that it is an header file. So it includes predefined functions like printf and scanf statements. It uses to include, if there is no header file, we cannot use a predefined functions. We cannot use output and input functions like printf and scanf statements. So include stdio.h we need because we want to use input and output statements. So it is an header file. We commonly use include stdio.h. So it is a header file. We're gonna start here, but the actual code starts from the main functions. So int is an integer value. It returns the integer value. If we can also use a void here. If we use void here, we're gonna not write a return zero statement. If we use integer value, so we have to write a return value statements. It return a integer value. Okay, it's a main function. It's the actual code starts from here. Next here, the open bracket. This opening curly bracket marks the beginning of the main function. All statements of the programs are written inside this bracket. All the programs and the functions what we are giving, what are the statements we are giving, all are written this inside this flower bracket. The flower bracket will opens here and the closes here. Here is the printf statements. Here is the input statements. Here I printed hello world. I got the output as hello world. Here I giving what I want. It can display in output. I printed here hello world. Then I output got hello world. So this is a printf statement. It used to display output on the screen. Here it prints hello world as the output. Every statement in C ends with a semicolon. We use output and input statement like printf. Any statements we use to use a semicolon. If there is no semicolon, there will be error. If we use scanf statements, there will be a semicolon. But in conditions like if else or for statements, there is no semicolon. But if we use output and input statements, there will be a semicolon. Semicolon tells that the compiler that the statement is complete. If there is no semicolon, there will be an error. Semicolon tells the compiler that the statement is complete. Here is a return statement. Why the return statement will use it? Because the program will execute it successfully. If we use here integer statement, so we use return statement. If we use void statement here, we do not use a return statement. It tells that the compiler executed successfully without any errors. No, the program without any errors, not the program will execute it successfully. If we use a here integer, if we use void here, we do not use return statement. So the closing bracket here, the flower bracket will closes. After this, the program execution stops. After this, the program execution stops. So the structure of a C program includes header files, main functions, and statements, and the return statement. If you understand, the program will start here. It's a header file. For you, why we use this? It uses for input and output functions like printf and scanf statements. The actual code starts here. Int is an integer value. It returns an integer value. Here the flower bracket opens. Here what we want. They will have to print here the hello world I printed. That the output will got a hello world. Here is a ending of statement. It says that it says the compiler that the program will execute it successfully. Why we use return statement? Because here we use it int here, so we use return statement. For example, I show you code blocks. Uh, show you structure of C program in a code blocks. Sorry. Now to run the program. So here we got a hello world. So this is the output we got. Okay, what we have printed here. So what we have printed here, we have printed hello world here. So we got the output as we got the output as So we got the output as hello world. Wait, it is not responding. So what we have printed here, the same output it got. Okay. If you find this video helpful, please like and share, and let's learn and grow together. Bye.